You know that feeling, right? You step in front of a funhouse mirror and suddenly you're 10 feet tall, or squashed flat, or even completely upside down. It's hilarious. But what's really going on there? Well, today we're going to solve the funhouse mirror mystery. Okay, so take a look at this. You've got this girl, Mina, at a science center, and she's totally confused. I mean, look at her face in that mirror. It's gigantic. But then her brother, in the same exact mirror, is flipped completely upside down. How is that even possible? It's one piece of glass. And that really gets to the heart of it, doesn't it? Why do curved mirrors mess with our reflections so much? A regular flat mirror, you get a perfect copy. But add a little curve, and everything goes haywire. The secret, though, is actually way simpler than you'd guess. And you know what? You don't even need a fancy funhouse or a science center to crack this case. Nope, the clue is probably sitting right there in your kitchen drawer. Yeah, I'm talking about a simple, shiny spoon. This is the cool part. A shiny spoon isn't just one mirror, it's two. Look into the part that holds your soup, the indented side, and poof, you're upside down. But then flip it over to the back, the part that bulges out, and suddenly you're right side up again, just a lot smaller. Seriously, you should totally try this. Go on, pause this and grab a spoon. Seeing it for yourself is the best way to get it. That little flip, that's the entire principle we're about to break down. It's literally physics you can hold in your hand. Okay, so those two sides of the spoon, they actually have official sciencey names. They're the two main types of spherical mirrors, and they're behind all those wacky reflections. So let's meet them. All right, first up is the concave mirror. The easiest way to remember this one is that it caves in. Get it? Concave. It's a surface that curves inwards, just like the inside of that spoon, the side that turned you upside down. And yeah, you can really see that inward curve here. It's this exact shape that lets it do two different things. It can make you look huge if you're close, or it can flip you upside down if you're further away. That's exactly what was happening to Mina at the Science Center. And on the flip side, literally, we have the convex mirror. This one does the opposite. Its surface curves or bulges outwards. Just think of the back of your spoon. And here's a look at one. See how it bulges out? What this shape does is it takes light rays and spreads them out. And because it spreads the light, the image it creates is always upright, but it's also always smaller than the real thing. So let's put it all together. This is basically the whole secret of the spoon in a nutshell. Concave curves in, like a cave. It's the wild one. It can flip you or magnify you. Convex curves out. This one's more predictable. You're always going to be smaller and right side up. Okay, so this is cool and all, but it's not just about funhouse tricks and kitchen utensils, right? Not at all. These two types of mirrors are actually super important pieces of technology that we use every single day. Let's look at where they're hiding in plain sight. All right, picture a car headlight, or even a really powerful flashlight. That super shiny bowl-shaped part behind the light bulb, that's a concave mirror. Its whole job is to grab all that light that's scattering everywhere and focus it into one powerful forward-facing beam. Super, super efficient. Or how about this, the dentist? You know that little mirror on a stick they poke around in your mouth with? Yep, that's a concave mirror too. By holding it up close, they get a magnified, zoomed-in view of your teeth. It helps them find even the teeniest, tiniest cavity. Okay, so what about the other kind, convex mirrors? Well, if you've ever been in a car, you've used one. The side view mirrors on pretty much all vehicles are perfect examples. And that's why you always see that little warning etched on there. Objects in mirror are closer than they appear. Because the convex mirror makes everything look smaller, it can squeeze a much wider view into that little space. It gives the driver a huge field of vision, helping them see what's in their blind spot. The trade-off? It kind of messes with your perception of how far away things really are. So we've covered what these mirrors do and where we use them, but the biggest question is still why? Why does just curving a piece of glass change everything so dramatically? Well, it turns out that all mirrors, flat, concave, convex, all of them, play by the exact same single beautiful rule. Okay, to get this law, we just need to learn a couple of terms. It's easy. First, just imagine light traveling at a perfectly straight line. We call that line a ray. So the ray of light that hits the mirror, that's the incident ray. And the one that bounces off, you guessed it, the reflected ray. Now, to measure exactly how that light bounces, we need a starting point, right? A reference line.
So what scientists do is they draw an imaginary line that sticks straight out from the mirror at a perfect 90-degree angle right at the spot where the light ray hits. And this handy reference line is called the normal.
Okay, now that we have our normal line, measuring is a piece of cake. The angle between the incoming light, the incident ray, and our normal line, we call that the angle of incidence, or just I. And the angle between the bouncing light, the reflected ray, and the normal, that's the angle of reflection, or R. And here it is, the big secret, the first law of reflection. It's this simple. The angle of incidence is always equal to the angle of reflection. Angle I always equals angle R. That's the whole rule. It's so simple. But when you apply that rule to a curved surface, where that normal line is pointing in a slightly different direction at every single point, that's what creates all those incredible mind-bending effects we see. And there's just one last little rule that keeps everything organized. The incoming ray, the normal, and the reflected ray all lie flat on the same surface, what we call a plane. It's kind of like playing pool. When you hit the ball against the cushion, it doesn't just randomly fly off the table, right? It stays on that flat surface. This just means reflections are predictable and follow the rules. They're not totally random. So there you have it. From a crazy funhouse mirror all the way to the headlight on a car, it all boils down to the shape of the curve and one simple universal law. Pretty cool, right? So now that you know the secret, I'll leave you with a question. Where else do you see light being bent and shaped in the world around you?